Fantastic. So here we go. I'll just go into the textbook first, and we'll go over really quickly. Do you guys remember what discrete means versus continuous? Anybody remember what's the difference?
Discrete is like whole numbers, and continuous is like...
Yeah, continuous goes over a range, and discrete like jumps from value to value. So as you can see here, even in the picture up here, you can see we jump from 1 to 3, and then we jump all the way to 7. So discrete data has gaps in it. So a discrete probability distribution is merely a probability distribution that is using discrete data. So what's different about this is that, are you guys okay with the screen? Do I need to make it bigger? Are we okay?
It's fine.
Okay. We're going to now, instead of having with continuous distributions, we had graphs. We're going to now have tables. And here's an example. At the bottom there, we've got, this is Jason, has been playing in a softball league. On any given at-bat, the probability of each outcome is given at the table on the right. So if you can see the table on the right, what is the probability that there will be at least one runner on base at a randomly selected at-bat? So when Jason gets up to bat in his history, we've seen over here on the right on the table, ooh, I wish I had done what Joel did. Joel made his mouse like really big and really bright, and I forgot to do that. But anyway, over on the number of runners on base, there could be nobody on base when he gets at bat. That would be the 0, and there's a 30% chance of that happening. There could be one person on base. There's a 45% chance of that happening. There could be 2 people on base. There's a 20%. And there could be 3 people on base. Why can't I have 4 people on base?
Only 3 bases.
There's only 3 bases. Thank you. Jaden, all right, there he is. Okay, so if I were to ask you, I'm just going to ask you some questions. So you guys, you might want to sketch this table out if you can't see it very well on the screen. But right now I want you to tell me what's the probability that Jason comes up to bat and there is less than 2 people on base. What's the probability if he comes up to bat, there's less than 2 people on base?
$75%.
Ooh, wow, someone was fast there. Who was that? Who was that?
Noah.
Oh, Noah. Wow. So how'd you get that, Noah? You're muted. There you go.
Yeah. I added a 0.3 with a 0.45.
Okay. So what Noah did and what his brain did really fast, something that I want to make sure you guys understand is that I want you to write this notation. Forgive me, I'm using my mouse, but we want probability. The question was probability that X is less than 2. And I know a lot of you, a lot of times on the worksheets, we write this out for you, but you've got to be able to come up with that notation. So the probability that there's less than 2 runners, because X represents the runners. So I want you to be able to write this notation. And then what Noah said he did, so technically what he did was, here's 2, right? And so what's less than 2? 1 and 0, right? Okay. And then he grabbed the probabilities that belong to those events. So he took the 0.3, and he added it to the 0.45. This is the idea of the ORs, because you can't have both nobody on base and 1 person on base. So we use the OR situation where we're going to add these together. So 0.75. Okay. Any questions on that one? All right. Do we have, I want you to look at this one down here and notice they went through, when we're looking for at least one, at least kind of get people, I didn't write it here, but how would you write that with the X notation? At least one would be probability of what? Go ahead and write down what you think that notation would look like. At least and at most kind of mess with people's head because they hear the least, but at least means one is the bottom, and I'll take everything above. So at least one would be one or more. So this would be probability that X is greater than or equal to 1. Lavario, are you there yet? Lavario Wiley.
Yes, sir.
Yeah, there you go. I know, it's early. Earlier for some of us than others. Okay, so probability X is greater than or equal to 1. And then notice, so basically this scenario calls for everything except for, I'm going to erase the old one. Everything except for 0. So notice here they added up all the other probabilities, but what I would actually do is if I know that I'm adding greater than or equal to 1 would be all of these events, right? So what I would do to make my time shorter is realize, hey, that's everything except for 0. Why add up all these when I could just take the complement, 1 minus the probability of 0, and then I get 1 minus 0.3, which is that same 0.7. So you can solve these things. It's a really wonky 3, but you can solve these things. Either if you think about using the complement, that's fine, and you can add every single event as well. Yeah. Okay, so we've got, there we go, cool. So anyway, when it comes down to it, Jason has a 70% chance of having at least one runner on base, which means he could get an RBI. Then moving down here, oh yeah, I've got to clear all those drawings. That's right. Clear. As we move down the screen, now this table right here, this graph now, this is a graph of a discrete probability distribution function. Remember, when it's continuous, this appears as a curve, but because we have gaps in the data, we're jumping around, and so the discrete graph looks like sticks. So notice it's the same data that we saw in the table. I can't get both of them on the screen, but the 0 has a 30% chance of happening, same as we had here. 0's 30% chance of happening, and so on. So 1, 45%, and so on. So when you put it in this form with the graph, it's sometimes easier because I usually get in the table, I say, hey, what's the mean? And everybody goes to the middle here. They don't even look at the weights of the probability. They just say, hey, 1.5, but that's not the mean. The mean is actually a little closer to the 1 and the 0, because you can see more 1s are happening, more 0s are happening than the 2s and the 3s. So when we calculate a mean in a distribution, it's called the expected value. So this is what we're going to do in StatCrunch, and I'm probably going to jump to StatCrunch to go ahead and do that. Okay, so we'll be ready in StatCrunch. Any questions, though, on the table and the graph versus the graph here? When you have the graph as well, you can still use the range rule of thumb to guess at what the standard deviation is. It's not going to be, so like here, what's the range? Who knows the range on this distribution? Everybody write down, what's the range of the data? You might be able to see the range better here. Anybody got it? Or should I call randomly on people?
These are for spins, by the way.
Ooh.
You participate.
Yeah. What's my maximum number of runners on base for Jason?
3,
3. What's my minimum?
0,
What's my range?
0 to 3.
Yeah, remember the range is always the max minus the min. That hasn't changed. Max minus the min. So my range is 3, and the range rule of thumb to estimate standard deviation is just divide that by 4. And so standard deviation would be 0.75. All right, so let's go to StatCrunch. And so do you guys all have this open? And if you want, you can, if you have a surface, you can write on it here, or you can, what was I going to say? Or you can just take a pencil and paper and write your answers on a pencil and paper separately. You guys ready to write? Because this is going to be due tonight.
Hold on.
Mm-hmm. Let's get prepped up here. I want my contacts. Ooh, I didn't even realize. I'm in annotate, so I can't click. Okay, we all ready? Oh, fantastic. There's more people here now. What happened? You guys gotta get here at 9. Good times. Okay, so we're going to be playing a carnival game, and it's basically consisting of tossing a 4-sided die and a 6-sided die, and we're going to add those together. So if I roll a 2 and a 3, when I add those together, that means I got a 5, right? So the player wins if the sum is a multiple of 3. So first thing, what is the observational unit? Going back to old school, what is it that we're watching, and what is it that we're recording? What is the variable? So everybody write down right now what you think the observational unit and the variable are, and then hold your answer up to the screen. I want to see what you said. What do you got, Lavario? What do you got, Matthew? Let me see what you got. What do you think? What do you think the observational unit is, and what is the variable? So we're tossing 2 dice. Ooh, okay. So 4-sided and 6-sided die. Getting close. Getting close. What about those dice, Sakina? What about those dice that we're watching? Ooh, I saw somebody else was holding something up for me. Move it in a little bit more, Matthew. Okay, is that what you're showing me, is that the observational unit or the variable? Some of you are really good at stalling. Who's going to be wrong for me? Who's going to be wrong? So far, I've had a couple wrong, and they're okay. They at least tried it. Show me something. Show me observational unit. There we go. Lavario, move it in a little bit more, please. Can you read that, Michael? Read it out to me, Lavario. Unmute yourself. I got. Oops, sorry. I'm unmuting you. And then you're unmuting you at the same time. Can I hear you? Yeah, go ahead. Read what you wrote there.
I said the observational unit is 11.
Is 11?
Yes.
Okay. So what made you think of the 11?
because I just added
Mm,
4.
okay. So I saw Devin, what'd you write there? You were just looking
I
at,
just put the sum of the two dice.
you wrote the sum of the two dice. Was that the observational unit or the variable?
The observational unit.
Okay. And go with the other one. It's the variable. So the variable, what we're recording is the sum of the two dice. Okay. So what we're recording is the sum of the two dice. So that's the variable. I think a few of you got that one. And then the observational unit was, I don't think anybody got this one, so we've got to work on this. Sakina was the closest. I think she said something about, you know, a 4-sided die and a 6-sided die. So Sakina, you were close, but what were we watching? Did you ever figure out what are we doing with these dice? Are we looking at, are we observing, you know, the shape of the die? Are we sure? What are we observing?
The faces
What are we doing with the dice?
where we're finding the sum of their faces.
Yeah, but before you find the sum, what do you have to do with the dice?
Roll it.
Yeah, you have to roll it. So the observational unit is merely, they referred to it as a toss up here. So the observational unit is a toss of the die. Boom. So not just the 4-sided die, the 6-sided die. It's actually the roll of the, and actually not die. It should be dice, because there's 2 of them. Okay. So this grid over here is really helpful to see what the sample space and what are all the possible numbers that I could roll. And so over here on the left, we have the, over here, actually, I'm going to use the spotlight, see if I can, that's cool. Over here on the left, we have the 4-sided die. You could only roll a 1, 2, 3, 4 on that. And over here on the right, we have a 6-sided die, 1, 2, 3, 4, 5, 6. So when we roll a 1 and a 1, our outcome is going to be a 2. So we would just write a 2 in this box. Boom, there you go. And you'll notice there's a nice pattern to it. When we roll a 2 and a 1, we're going to get a 3. When we roll a 3 and a 1, we're going to get a 4, and so on. And so go ahead and fill out this chart on your paper. And I will catch up. I'm getting better at using the mouse. Feeling very confident. Uh-oh. Somebody let me know if I'm filling in the wrong things too, because I'm just doing it. I'm just focusing on my mouse work.
So, Angie, you can also use an iPad, and if you have one, and then you can use Notability on the
Yeah.
iPad.
No, I usually use on my Surface and stuff. I use Drawboard.
Oh, okay, okay, cool.
Yeah. That's
Okay,
why this is, but I was like, but I like just with this, I like the bigger screen. My eyes are getting bad.
right, yeah, yeah. Also,
And I don't want
you can invest in a Wacom board. I don't know if you know what that is.
to, ooh, I'm sure Marie does.
Yeah, so it's just it's a tablet that you attach to your computer, and then
Oh, that's right. I think,
it's only like $100, and
yeah,
then you can write directly on.
dude, I think we
It's like
have one of
virtual.
those somewhere.
Yeah, it's like virtual paper. You probably do. And
Mm.
so
Yeah, I need one of those.
yeah,
Thank you.
yeah.
Okay. Does everybody see what I got here? Does everybody agree with what I have here? When I roll a 6 and a 3, I get a 9. A 6 and a 4, I get a 10. Anybody have any questions on these? So this is just a tool that I use when I roll dice. You don't have to do this grid if you understand, you know, if you can visualize all the possible ways. But this helps me to kind of see it straight up. I know the lowest I can roll is a 2. What's the max I can roll?
A 10.
A 10. Very good. And so then I know everything else. And then when I see it this way, I can see how many ways I can roll all these things. So the X is everybody with me? Are we all? Give me a thumbs up if you're with me. Thumbs up, thumbs up. Okay, all right, cool, cool, cool. Oh, very good, very good. So now if I want to make a table for the probability distribution, remember that X is the sum of these two dice. So what I'm going to do is just create my table. Ooh, 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 ooh. Oh, what is that? No, that's not what I want. I thought I found something cool, but I didn't. So I'm going to have a 2. It's basically it looks like a frequency table, and X is my sum of the 2 dice and my probability. So just by doing this, by labeling one thing's probability and the other thing is my random variable X, this is what we refer to as a probability distribution for a discrete value. And so I'm going to write all of my values from 2 to 10. 2, 3, 4, 5. I'm probably going to go off the page here. Dot, 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 dot. And then to get the probability, this is where this grid is helpful. I can see that even though there's only, what is that, only 9 outcomes? Yeah. There's a bunch of ways to get them. So there's 24 ways. We've got a 6 by 4. There's 24 ways to get all of my outcomes. So the 2, the 2 only happens once. So I'm going to put that over here, 1 out of 24 as my probability for the 2. Okay. And then the 3 has 2 out of 24, and you can complete the rest on your table. When you finish your table, go ahead and show it to the screen. Just put it up to the webcam, and I will, Michael, your professor, and Alex and I will check them as we see them. So you're writing down on the left the sum of the dice, and on the right the probabilities. Let's see, Noah, go all the way down. You got it all the way to 10? Oh, fantastic, man. Move in a little more. And the last one was 1 at perfect. He's got 1 out of 24. I highly, you'll rarely hear a math teacher say this, but I highly recommend that you do not simplify fractions because it's easier to add them up and see that you've got all of them if you have the same denominator. Who else has got it?
Good job, Samantha.
So I'm going to use StatCrunch to clear all my drawings. I'm going to use StatCrunch to show you this a little better. BJ, where you been, my friend? But it's really good to see you. He's like, oh no, I know that voice. I know that voice. It's too early for that voice. So I'm going to cruise into StatCrunch to kind of, so that we can see this better. We've got on the dice, we've got the sum of the dice. and then we've got the, so you guys have the probability. I'm just going to write frequency, because when we write it on our paper, we want to write the probability distribution, but StatCrunch is kind of funky because it will not allow me to put in probabilities to calculate means and stuff like that. So I just have to think of a perfect world scenario. So we've got the sum could be a 2, 3, 4, 5, 6, 7, 8, 9, and a 10. Those are all, that's all my data. That's what I could roll. And then for the frequency here, where you guys would have 1 out of 24, 2 out of 24, we're just going to write the numerators, okay? So for 2, it would have 1 in a perfect world. If we rolled the dice, and I'll even write that, frequency of 24 rolls. So if we rolled the dice 24 times, in a perfect world, we would get exactly 1, 2. We would get exactly how many 3s? Everybody unmute right now. I want to hear you yelling out how many we got of everything.
2.
Bijan, I may have to, we're on the, BJ, we've got, let me show you. We opened this, we're doing this discrete distributions with simulation. Okay. If you open that so you know what we're looking at.
Okay.
All right, come on, Jaden, unmute. How many 3s you going to roll in a perfect world of 24 rolls?
2.
2. How many 4s are you going to roll?
3.
3. I don't want to hear, I don't want to, okay, Samantha, you met your quota. Let them catch up now. What's that? Oh, good for you. How many 5s? How many 5s?
4.
4 5s, nice. And 6s?
4.
Why won't it let me write? Oh, there we go. Okay, 5 6s. How many 7s?
6.
6 8s.
7.
Sakina, you made a face. What's going on there?
Oh, I got different numbers, but I think I did it wrong.
No, I don't think you did. You speak up, girl. What are you seeing?
I got, for 5, 6, and 7, I got 4.
For 5, 6, and 7, you got 4?
Yeah.
I think I got that too.
Yeah.
So
Yeah.
make sure you're paying attention. So the 5s, right, is rolling like a 3 and a 2. There would be a 5 here, and then there'd be a 5 here at 3 and 2 there, and 4 and 1. So 1, 2, 3, 4 5s. Notice the 6s, there should be 1, 2, 3, 4 6s, and the 7s, 1, 2, 3, 4 7s. So thank you for at least making a face, Sakina, so that I knew somebody was following along. So we've got to fix these. The 6 only has 4 ways of happening. The 7 only has 4 out of 24. And then the 8, it starts to go down again. Does everybody see now where your mistake was? I know you were just going with the pattern and you were just saying the number that came after 4, but we've got to go with what's on the, dude, Samantha, I totally thought that was a bottle of Jack. I'm like, dude, it's too early. That freaked me out. It's not recording. Okay. Is it recording? Oh, dang it.
It is recording.
Shoot. I'm like, Samantha, dang. But anyway, so out of 24
At least I was drinking wine.
That's what editing is for.
I know, right? Marie, get on that. But it freaked me out. My eyes got like super big. I'm like, what is she doing? Okay, so this is our distribution. What's kind of cool is that this is the table, but for you guys in the table, you've got 1 out of 20. All of these are out of 24, correct? If you go to Stat Calculator and we go to Custom, and we build this custom distribution. So down here on Custom, for a discrete distribution, you're most likely going to have to use a custom distribution unless it's uniform. And so my values, my variable that I'm looking at is the sum of the dice. So in values, I'm going to put sum of dice. And my weights, these are my weights for if I were to roll 24 times. So I'm going to put my weight frequency of 24 rolls. Is everybody with me? Does anybody need to see where I got that? It's in the stat calculator. And then when I push compute, now look at that. Isn't that pretty? This now shows me exactly this is my distribution in a graph form. We had a table. This is now the distribution in a graph form. Notice the 6, the 5, the 6, and the 7. That's that 4 out of 24, which is 1/6, right? That height is 1/6, and it gives you the nice distribution in graph form. Okay, so looking at this, to me, it's much easier to see what's the mean of this distribution. What's the mean? The mean is a measure of center. What would the center be of this distribution?
See?
Yeah, it's symmetric, right? So this is kind of showing me, hey, the 6 is in the middle, and then my standard deviation, and they've told us that too. They've told us the 6 there, and then the standard deviation. Notice if we did 8 divided by 4, if we use the range rule of thumb, 8 divided by 4 would get 2, and the standard deviation is actually a little more than that, just 2.04. Okay, and notice this will calculate probabilities for me. Again, same as the other ones. If I wanted between, I'm going to roll between a 6 and an 8. It'll disappear for a while, but when I push compute, bam, now it changes. These are the probabilities I was looking for, 6, 7, 8. Okay. If I do, what's the probability that I roll less than a 10? Or a 10 or less? What's the probability that I roll a 10 or less? You should know this immediately. A 10 or less should be what?
100%.
100%, because all of my values, so notice all of them come up red. All of my values are 10 or less. So bam, 100% there. What's a way that I could get the probability to be 0? What could I set up to make the probability 0 here? An impossible. What's an impossible event?
If you roll a 0.
To roll a 0. So unfortunately, we've got. Let's put less than 0. Is that okay? If I put less than 0, bam, none of these. My probability is going to be 0. Okay. So that's one way, and you can sketch the discrete distribution on your paper as well if you want in the graph form. Let's go to MVP spinners. We should get an MVP spinner. Who was here? Who was here first? Sakina and Samantha. Take a moment. So notice, and this is actually kind of cool. If you guys look, my MVP spinner. This is my discrete distribution for my MVP spinner. I've got the 10, you guys probably noticed, the 10 doesn't happen that much. It's only 5 times out of, I think this is 100, 50, yeah, 100. And the 5 happens a little more regularly, but still not much. The 3s and the 2s happen the most, and then the 1 is kind of in between. So when I do my spinner, that's why you're seeing, the 10s don't come up that much. You're really lucky. I need to go to applets. So spinner. Sakina was the first one here for the peregrines, and Samantha was the first one here for the kestrel. So let's give them a spin. Here we go. Sakina, you got 1, Sakina. Samantha, you got 1.
Cara.
Cara. Very good. So Samantha's in Cara. Fantastic. But anyway, back to my other screen. I'm going to plug this out. Let's go back here and see what we have to do next. So now we're going to simulate, just like we simulated yesterday with continuous distributions. We're going to simulate rolling so that we don't even have to roll the dice 1,000 times. In a second, StatCrunch is going to roll the dice for us, and then we're going to create a histogram. So first, each of us has to simulate rolling the dice 1,000 times. So let's do that. So we go to data, just like yesterday. Data, then where do I go? I'm not going until you tell me.
Simulate.
Simulate with enthusiasm. Fantastic. And then custom down here, because we're doing a discrete distribution that's none of these above us. So we're going to custom. All right, unmute everybody. What are my values going to be? What do I select for my values?
Sum of dice.
Mm-hmm. And my weights? You're not unmuted, Devin. I want to hear you, man.
Frequency.
No, I want to hear you. What's going to be my weights?
Frequency of
Everybody.
Frequency of 24.
Frequency.
Hey, frequency is my weights. Absolutely. So now, how many rows am I going to want? Remember, our rows is going to be how much data we want. How many times do we want to roll this die?
1,000.
1,000. There you go. And then we're just going to use one column. And then I'm gonna name it 1,000 rolls of the dice. So in the that's the only extra added goodie we have. You can choose if you want to open your data in a new table. Sometimes people like to get a clean sheet, but I'll be okay. And then I just push compute. Does anybody need to see the inputs again? We're good? Okay, compute. Bam. So we each got something different because this is like each of us rolling the dice 1,000 times. I first rolled a 7, then I rolled a 10, a 6, a 7, 7, 8, and so on. You might have rolled a 5 first, something a little different. But in the worksheet now, we want to create a histogram, and we're going to start at 2 and have a width of 1. So I'm going to stop my share. And who wants to share their screen and show me how they do this? Random? We going BJ. We going BJ then if nobody's going to go. Come on, Bijan. Share your screen, my friend. You know it. If nobody volunteers, I'm going to you, man. You're Buena Park Stallion.
Wow, like, yeah, man, like somebody, what are y'all gonna help with, like, ladies? Who y'all at? Just to help me out.
Ladies, he goes, ladies. Come on, share your screen. I'll talk you through it.
Do you want
All
me?
right.
Okay.
I'm for share right now.
Yeah, you got this.
All right, let me share my screen. All right, I'm sharing it right now. My stack control, right?
Yep, you're going to Stack Crunch.
All right, I'm sharing it right now.
All right, fantastic. So you need to create your column. So in variable 1, I need the numbers 2 through 10.
Oops. I can't even click to go back because this thing keep popping out.
Oh, up at the top of your screen, just click. There you go. Up, up, up.
I can't grab it.
Oh, you can't grab it?
Because this thing keep.
Okay. Go ahead and try to.
Okay.
You're almost there. There you go.
You can
Okay.
you can move that little bar at the top out of the way.
Yeah, you can move the bar. Click and drag it. Good call. I was wondering, Jason, what was happening. You
Yeah,
got it.
it's the sharing screen bar that's in the way.
Okay, so the you're right on it, BJ. Start typing in 2 through 10.
Right here, right?
Mm-hmm. I think you can just, do you have your keyboard? Right now, just punch in the number 2.
There you go.
There you go. Enter.
Enter.
3.
3.
Again. Yeah, look at go. 4.
Oh, my fault. It's 3 again, right? I was 4.
Yeah, we don't want 3 again. We want 4. All the way to 10.
All right.
Fantastic. Now in the other column in bar 2, we don't have time for you to name them, but in bar 2, these are our frequencies up at the top.
You said, huh?
Right under variable 2, next door, the column next door. There you go. That's put a 1, 2,
Already 10 again?
4. No, not to 10. Now I'll go back to 6. You need a 4 for 6, a 4 for 7, and then 3, 2, 1. Fantastic. Now go to data. Go to simulate. And custom at the bottom. I know sometimes it's StatCrunch can be like really mad at you, and go all the way to the bottom, custom.
Mhm.
Fantastic. Select the values are the var1. So in values, var1. And weights, var2. And then in the column name, put 1,000 rolls of dice.
And this one, right?
Mm-hmm.
And how many rolls are we doing?
We're doing 1,000.
1,000. So number of rows and columns?
Oh, sorry, my bad. Go ahead, BJ, go to rows,
Is it
1,000,
1,000?
and columns 1. And then compute. Yeah, it would have come up with an error for us and yelled at us. But all right, you rolled a 4 first, but now you're going to go to graph, BJ,
Yes, ma'am.
and you're going to go to histogram. And you're going to click 1,000 rolls of the dice. And now under bin, not yet, don't be so, under bins, we're going to start at 2 and give us a width of 1. This way we'll see each and every outcome. Does everybody get that? If you start at 2, you'll get the 2s. If you make your width 1, the next jump will be to 3. Okay. And you'll probably want to put the value above bar. Click that little box there and display options underneath, down. There you go. Down a little. That little, yeah, check box. There you go. And compute. Okay, nice. And so each of us have a slightly different graph, but you can see it models that distribution that we saw in the sticks, right? It's looking a lot like that distribution. So what's the next thing in the let me see. What's the next thing in the worksheet that we've got to do? We've got to, oh, you're supposed to attach it to this document. But now we're going to find the mean and the standard deviation for each of these 1,000 rolls. So I'll go back to BJ. You're going to now, how do you find the mean of that column 3? How do you find the mean of that? Go to stat. And then go to summary stats and columns in this case. And then 1,000 rolls of the dice. And then guess what you're going to click down there? If I want to know the mean, what are you going to click? Mean, boo, fantastic. And you could have just left it because it was doing it, but I like to be specific. So go compute.
Oh, can't see it right now. Hold on. Right there you go.
There you go. So BJ's mean, look how close that is to what we know is the actual mean of 6.0. Because he did 1,000 rolls, it's very close to the truth. What'd you get, Noah, when you did the mean of your distribution?
Wait, how did you do the mean again?
Okay, so you go, show them again, BJ, go to stat. Go to summary stats.
Oh, sorry. Summary stats. Go to column. Oh my God. They don't like me right now. Hold on.
Okay. And then you go to columns, and then you put in your 1,000 rolls of your dice, put the mean, and BJ, do me a favor, hold on. Hold the control key and do standard deviation too. Let's see everybody's standard deviation as well. So hold your command or control key down and click standard deviation. Beautiful. And compute. Did you get that, Noah? I know it was kind of fast. Okay. Okay, so BJ, you can go ahead and stop sharing right now because I want to go through a couple of things with Professor Hultman really quick. I'm going to do a fast forward for a few of you. So Jason, just so you know, Jason, I wrote this in the textbook, but I know you've used StatCrunch before, but I don't know how, but just know the warning in StatCrunch is that you have to always use positive outcomes for your distribution, like because for some reason it doesn't give you correct answers when you have negative data. I don't know why, but it doesn't. And then your frequencies always have to be integers to use the next thing that I'm about to use. So I put that in the text, just that was mainly for the instructors. But let me show you, I'm going to share my screen. So if I wanted, without, you know, going into the stat calculator, if I wanted to get the population mean for the group bin data, I'd go to stat and the summary stats, but down here, if it's a probability distribution, we're going to go to group bin data.
Okay.
And then I'm going to put my bins are my my sum of my dice, and then my counts are in my frequency.
Okay.
But then what I have to be careful of is that when I do my when I get my standard deviation, because
Right.
this is a population, I'm looking for sigma, not S. So everybody aware, when we get standard deviation, that's assuming a sample. We're looking at S. But way down here, it's called unadjusted
Unadjusted, yeah.
standard deviation, and that'll give me sigma. So that we're not going to use it all that much. That's why I have them create 1,000, because it gets close enough.
Right.
But just so you know, as a professor,
Right.
the unadjusted is the population standard deviation.
Is sigma, okay. Perfect.
Yeah. So if I look at this, guys, and I go stat calculator, no, not stat calculator, summary stats,
Right.
and now I compare. Let's see. I always like to get my N.
Right.
Just like that. Oops.
Oops.
Yeah, there we go. Wait. Uh-oh. Not now. No diction right now. I want to start over because I want them in the same exact way. Columns, 1,000. There we go. So if I look at what I got, guys, so this one on the left, that's my population, even though it says N is 24. This is actually my population. This is the true mean and standard deviation of rolling those dice. Over here is what I got from my 1,000 rolls, and it's a pretty good approximation to the truth of the population. So notice 5.998 is extremely close. You know, I don't want to be like you. It's only off by 2, what is that?
2,000.
Tenths, hundredths, thousandths, right? I'm only off by 2 thousandths. And my standard deviation is only off by 7 thousandths. You know, that's really close since I did so many rolls of the dice. So you can either, whenever I ask you for the mean and standard deviation of a probability distribution, sometimes it might guide you through, like this worksheet does, and say, do the group bin data. But did any of you do the group bin data with me?
Yes.
Did any of you, Samantha, did you get the same exact things I got?
Yes, I got
Yes.
6
And
then 2.
Good, and you should, because that's a population. So that's the theoretical outcomes over here. And then on the right, Samantha, you should have got something different here, right?
My mean is 5.915, and
Yep.
then my standard deviation is 2.037.
Yeah, so you weren't as good as I was in approximating the mean, but you were still close enough. So we're going to get different values in the expected, and we're going to get similar values here. I know Professor Hultman, you've got to, let me see if there's anything else. And then this one just, it goes on, it now gives, it actually plays the game. But I think the rest of it, I think you should have it.
Yeah. Okay. Sounds great. I'll leave you to it.
Okay.
If when you leave, Professor Conley, if you could just give Alex the host privileges.
Absolutely, I will do that.
And I'll see you guys later. Thank you for being a great class today.
Oh, thank you. And so you got the next class, right, Jane?
Yeah, absolutely.
All right. Thanks, man.
Thank you. Bye.
All right. Cool. So, I meant to ask this before he left, but anyway, I wanted to get your guys' opinions on, so this is just a regular old worksheet that I used to have. And if you notice the past 2 sessions, we've used the hyperlink that where you can type things in. You guys know what I'm talking about? With the Gettysburg Address and with the where you
Yes, ma'am.
moved your graphs.
Yeah.
I just wanted your opinion on whether you like those or not, or whether you're, I don't know.
I like it better. I gotta copy and paste.
You like what?
I like it better.
You like it better to drag those in because they take a little time to make. So I wanted to make sure that it's worth, you know, if you guys want them, we'll make it. But if you're like, I don't care, you know, well, I don't have to spend that time. But I kind of like those documents because they show you exactly where you've got to put in answers and stuff. And they're easier to upload, right? Because you've already got them digital. Just make sure you know that you always still want to have your pencil and paper out for scratch work and computations, and you're always welcome, if you do write things down with pen and paper, you're always welcome to like upload that as well to show kind of like your backup work that you were doing. But we're going to try to make, I think, more of those I think they're called hyperdocs. Does anybody know? Michael, you don't know what they're called? Sounds like a trivia question to me. Okay, so who else wants to show me what you got for your mean and your standard deviation?
I think I should be able to pick.
What's that?
I don't know. I think I should be able to pick who next.
Oh, I think you're absolutely right. That must be a Buena Park stallion there. Go ahead. Who's next?
Oh, I'm picking up my football player. Lavario, you next. Come on.
All right, Lavario Wiley. You know, BJ, I really like that, BJ. I really like that. Pick who's next. Okay, Lavario. So Lavario, go ahead and share your screen, my friend.
Oh, I bought a computer.
Okay, that's fine. Actually, just tell me what your mean and your standard deviation was. I'll use your results. I can share my screen. I'm sharing my screen, and I can just use your results. So what do you got?
My mean was 6.02.
Okay. So mean was equal to 6.02?
Yes.
Okay. And what was your standard deviation?
4.
4 exactly?
4.03.
For your standard deviation?
Oh, it's my variance, so I don't know if it's...
Oh, okay.
Yeah.
Yeah, show me your screen right now. Go in there. Okay, so I don't want variance. So go back in, do summary stats again. What would you say your variance was? 4 point what?
4.03.
03. So the standard deviation is actually going to be the square root of that. So if you want to take a calculator and take the square root of 4.03, you can do that as well.
Okay.
So the square root of 4.03.
$2.0. Huh?
2.0.
0.07.
Okay. So that's your standard deviation, 2.07. So what you would write when when it says interpret these values in the sentence or 2 is, if I were Lavario, I would write, what does this 6.02 represent? What does the mean represent? What are you doing in the problem?
Yes,
Yeah,
me?
Lavario, go with it.
Oh, you said, what is the mean doing?
What is this whole experiment? What are we doing in this game?
See how much times for like dice, like.
Yeah, we're rolling dice. That's all we're doing. We're rolling dice. So the mean, we'd say the expected value, I think we're summing the dice. The expected sum in a roll of the dice would be 6, and you know, it would be 6.02, even though we know we can't get that. We know that we could get an average of that. If we rolled this die 1,000 times, we could get a sum of 602. But it would be 6.02 and then comma, give or take 2.07. So each of you will have a little something different, but you can always, when we're talking about the mean in a probability distribution, we're talking about the expected value we're going to get. Okay. So we wouldn't be surprised if we add 2 to 6. We wouldn't be surprised if we got an 8. We wouldn't be surprised if we got a 4. We would be surprised if we got a 12, and in this case, it would be impossible, right? But a 12 would be 3 deviations beyond that 6, so that would be very surprising. Oh, was this was your mean and standard? Oh, this was for the 1,000. Okay, and then for let me see if you can you copy and paste these? You can't. And then again, in the population, we got that the mean, we all had the mean was 6, exactly 6, and the standard deviation was, what was the standard deviation? 2.04, I think. Is that right? And again, how close are these parameters? Well, the mean is only different by 2/100ths. Do I see where I get that 2/100ths? This mean is 6.0. And the other mean was 6.202, sorry. And the standard deviation, this is a weird text box. Come on, come on. There it is. And the standard deviation differs by, what is that? 3/100ths. So we're pretty darn close to what we would expect. 2.04. And again, so for you guys, this is Lavario's answer. You don't put 2/100ths for you. Actually calculate how far was your mean for the sample from the mean of the population. So how far was whatever you got, you know, I got 5.998. So I would have been only 2/1000ths away. So I'm pretty close to that. Do you mind, Alex, if I keep going? Oh.
No, I don't mind. Go ahead.
Oh, you don't? Okay, good, good, good. I thought you were like, bitch, get up. No, sorry. It's not being recorded. It looked like your face was like, oh my gosh, you're taking my job. Jaden, how you feeling with this?
Pretty good.
You're okay?
Yeah.
Okay. All right, so let's go back. Is everybody okay? Can I clear this annotation in Zoom?
On your own.
What's that?
Yes.
Okay, cool. So I'm going to clear that. And then we're going to move on to the next part. So now the carnival wants to make money, okay? And we've got all of our values in here, and you can use your old thing. I can't bring my annotations around. So I've got the 2 here. I'm just going to keep going while you read the problem. Who's going to read it to me? Who hasn't talked yet? Lavario, go with it. Lavario, you're still on the hot seat. There you go. You read it.
In order to raise money, the carnival coordinators decide to charge $5 to play the game. If a player wins, the player will receive dollar amount equals to the sum of the two dice. Highlight the winning outcomes on the previous page, then let Y the amount won or lost by the player of this game and create a discrete probability distribution table or graph for the amount of money a player will win or lose playing this game.
Fantastic. How many of you are like freaking, what the hell did he just say? Right? There's a lot of information in our stats problems, and I don't know about you, but I personally have to read them a couple times before I move on. So go ahead, Devin, take it again. What did he just say?
You want me to read it again?
Yeah, read it again. And this time, while you're reading, I'm going to make some notes.
All right. In order to raise money, the carnival coordinators decide to charge $5 to play the game. If a player wins, for example, gets a multiple of 3, the player will receive the dollar amount equal to the sum of the two dice. Highlight the winning outcomes on the previous page, and let Y the amount won or lost by the player of this game, and create a discrete probability distribution table or graph for the amount of money a player will win/lose playing this game.
Okay. So notice while he was reading it that second time, I go through and I like to make some annotations. They're going to charge $5. So I like to circle numbers when I see them appear in a probability problem. And then kind of like underline things important. They're going to receive the dollar amount equal to the sum of the two dice. I also like to put boxes around words that are telling me to do something. So I put a box around highlight the winning outcomes. It's on the previous page, but we can do it over here. And then create. I create, what am I creating? A discrete probability distribution. So I like to go through these, a lot of the problems we're going to come up have a lot of information in them. So I really recommend, this is actually my daughter taught me. I call it the Allie method. She taught me this method because in math, a lot of times she has a little bit of trouble processing all the information they give. And so she said, oh, I circle numbers, I do this. And I'm like, man, that's fantastic. And a lot of my college students have used it because I think we forget, a lot of times we think, oh, we're in college, we don't need these tools, but we really do. It's hard for your brain to take in all the information. I'm trying to figure out does anybody know how to change the color on this darn drawing tool? Because sometimes it comes up green, sometimes it comes up orange. Anybody know?
I don't know.
Oh, I've got it. I think I figured it out, guys.
That was me.
It's under format.
Okay.
Oh, yay. Okay, check this out. So now what they want us to do is highlight the winning outcome. So we win when we do what? When we roll what? When does a player win? When they get a
multiple of 3.
Multiple of 3. So what are the multiples of 3? Is 2 a multiple of 3?
3, 6, 9.
There we go. 3, 6, 9. Oh, I didn't mean to push eraser. Undo that. I mean to draw. There we go. So 3, I'm going to circle the 3. I'm going to circle this 3. I'm going to circle the 6s, right? These are all my winning outcomes. And 9. These are all my winning outcomes. And I like this game because what you roll determines how much you win. So if I were to roll, if Y is going to be the amount I'm going to win, if I roll a 3, how much am I going to win? If I roll a 3, how much am I going to win?
6.
Yeah. It says I'm going to receive the dollar amount equal to the sum of the dice.
3.
So if I roll a 3, I'm going to win $3.
Oh.
Okay. If I'm going to roll, if I roll a 6, I'm going to win $6. Yes? And if I roll a 9, they're going to give me $9. So we want to roll, which do we want to roll?
A 9.
A 9. And then if we roll anything else, how much money do they give us?
Hello.
They give us nothing, right?
Nothing.
Yeah, but we are charging $5 to play. So we've got to think about that. So if we were to roll a 3, they're going to give me $3, but how much did I give them?
2.
2. So I'm actually out, or I gave them 5, sorry. So I'm actually out $2. Do you guys see that?
Yes.
Okay. If I roll a 6, they're going to give me
$1.
and I put in 5, so that I actually just won
$1.
$1. And then if I rolled a 9, how much did I actually win? $4. Now, notice what's very interesting is that a lot of us, when we make our probability distributions, and especially I think with athletes this happens too, because you're used to winning. But sometimes you don't win at all. So what's the worst thing that can happen on this dice? Rolling this dice.
-5.
We end up losing $5. So I have -5 as one of my values there. Okay. And now what are the probabilities? So the -2, losing $2. I'm going to make sure this is dollars. We know that. The $2 would be I rolled a 3. What's the probability of rolling a 3? From the other page? Probability of a 3 is? How many ways can I roll a 3?
2 out of 24.
2 out of all the 24 ways. And then the 6 is 4 out of 24. And then the 7, or sorry, yeah, the 9 is going to be another 2 out of 24. And then the -5 is going to be everything else. So I could just count up everything else, or I could subtract the 4, 5, 6, 7, 8 from 24, and I get 16 out of 24. Is that okay? I know mine looks like chicken scratch. So now we're going to go back to StatCrunch, and now we're going to simulate rolling the dice and playing with money. So every time we walk up, we're throwing down $5, and then we're seeing what we roll and see what we come away with. So going to, does anybody need to see this anymore? Or are you good with these?
Okay.
Okay.
Wait, we're sharing the screen again?
What's that?
I thought we were sharing the screen again.
You want to share the screen, Bijan?
Yeah, I want to see how to roll the dice, so that's what I'm trying to see.
Okay, okay. So, awesome. I will, you can see my screen, right?
Mm-hmm.
Okay, so let me get out of annotations. And I'm going to go back now to the game. So remember, back in the game, so this is now the, what is this? My net profit from the dice game. And we said that I'm either going to, the worst that can happen is I lose $5. Then I can lose $2. And now we're getting in the good stuff. I could win $1 and I could win $4. Game for money. I'm going to write, so that I distinguish it from the other one, I'm going to write, this is the frequency of 24 rolls, and this is for money. So I put that in there. So the -5, we said happened 16 out of 24 times. The -2 happened, what was that, 2? And all of these should add up to 20. Good, so 24. So. And now we're going to go in and we're going to go in and simulate again data. Let's roll those dice 1,000 times. We're going to custom my values in the net profit from the dice game. And I'm using the rolls for money. And do this 1,000 times. I'm going to call this 1,000 rolls for money. And for each of you, go ahead and calculate. Oh gosh, I don't like this. Look, I'm donating so much money. All these -5s. I don't like it. But for each of you, go ahead and find your mean and your standard deviation. Now, this is a sample. This 1,000 rolls. We could roll a die more than 1,000 times, so it's not the whole population. It's not the whole probability distribution. So when we do our stat summary, we're going to use the standard deviation for a sample. Get rid of the variance. So I got, on average, I'm losing $2.81, give or take $3. Okay, so sometimes I'm winning the $1. So this is kind of, again, hard to understand, but the mean is telling me whenever the mean comes up, and this is probably very comparable to a game in Vegas. The expected value of a game in Vegas is always going to favor the house. As a player, you're never going to see a positive expected value, or else Vegas, they take that game off the table very quickly, or they start charging you for winning if they don't see the right profits. But basically, this is like saying every time I step up to play that game, I'm basically going to be losing $2.81. Even though it doesn't actually happen, I'll either lose 2 or I'll lose, 4 or whatever. Even though it doesn't actually happen, in the long run, it would happen. If I played this game 100 times, I could be down $281. Okay. What other means did you guys get? Who's got a mean for me? Who haven't I heard from in a while? Michael Barrett? No. Jaden, what did you get for your mean?
Negative 3.065.
Cool. So you lost on average $3 each round. What'd you get, Devin?
I got negative 3.041.
Negative 3.041. Noah, what'd you get?
Negative 2.59.
2.59. Okay, so we all got something a little bit different, but we're hovering around 3, around like 2, a little like 2 in the upper ranges. But we're all going to use that for our own mean, or going back here. So I've got the mean and the standard deviation. Oh, I didn't do the histogram. So the histogram with X is -5. So I've got to do my histogram for my 1,000 rolls. Start at -5, and we're going to go just by 1 so that we can really see how this.
Wait, is it 1,000 rolls for money?
Say it one more time.
Did you select 1,000 rolls for money?
Yeah, 1,000 rolls for money. We want to see what our money outcome is. Thanks for asking.
Okay.
And then I push compute, and here's what it looked like for me. And check your graph. Does your shape look similar to mine? It's kind of like a lot of 5s, and then go back up. We go back up here because this is rolling the 6s, and they occur with much more frequency than rolling the 3s and the 9s. Okay.
What do we put for the bin?
What's that?
What do we put for the bin?
How can we make the bins?
What do we put for it?
Yeah, go in bin, start at -5. That's your lowest value.
Okay.
And then just jump by 1s so that we can see the actual dollar amount. So we can see from this graph, this is a losing game, but it's, you know, it's for the school, I think, carnival. So people might be more willing to lose their money to the school than Vegas. No, BJ, you're not willing to lose your money? Okay, that's good. That's good. And so you guys have already, at this point, you should be, we're done with J. We've done all the way through J.
Wait, who is Jay?
J, the letter
Oh,
J. And so now if we're at, so the mean, what I'm going to do is actually calculate the mean of the distribution by hand, right? Because we know from this StatCrunch over here, and I can do it by hand. I can't use, unfortunately, my group bin data because StatCrunch will do it wrong for some reason. So to get the mean, I just realized if in a perfect game, perfect world scenario of 24 games, I would lose $5 exactly 16 times. I would lose $2 2 times. I would make $1 4 times, and I would make $4 2 times. So to get the mean by hand, I'm going to insert another text box so you don't have to look at my scribble scrabble. So my mean, and again, remember mean is called expected value. And this is the shorthand notation. When you see that capital E, just like when you see capital P, you get probability. Capital E means expected value, which is another word for the mean or mu for a population. And so my expected value is going to be, there were 16 times I said I would lose $5, and I'm going to put a bracket here. Bracket, 16 times that I would lose $5. I'd add that to, how many times was I losing $2? Is that 4?
was it 4? Yeah.
Yeah, exactly. So back in StatCrunch, oh, it's annotating for me. Back in, redo, there we go. No, I want this one. Oh, well. So 4 times I'm losing $2. And then 6 times? What's the next one? How many times do I make $1? Let me go back to StatCrunch. So notice here, so here's what I'm doing. There are 16 times that I'm going to lose $5. There's 2 times that I'm going to lose $2. And then there's 4 times that I'm going to make $1. Okay. And then 2 times that I'm going to make $4. So when I calculate the mean by hand, I want to, oh, no, it's not letting me back in that text box. I'm going to now add all these up. So it was 4 times that I made $1, and then 2 times that I made $4. Yes? And I'm going to take all these and I divide by 24. So I'm going to add all those sums up, and then I'm going to divide by 24. And that's going to give me the true probability of this game. Barrett, are you on it? Okay. I'm losing, so I got 80 divided by 24, is that right? What does that come out to? Anybody got this? Matthew, did you calculate this yet or no?
You're talking about J, right? Or which one?
I'm talking about the mean right here that I'm calculating. I'm taking all these values and summing them up.
Oh, no, I haven't done that yet.
Okay. So go ahead and get your calculators out and sum those up. 16 times -5 plus 4 times -2 plus 4 plus 2 times 4. Add all that up. Get that sum for me. I think I've got it, but I want to be sure. What's nice is the -8 and the 8 here are going to take each other out. So I should be left with 84.
I had a -3.16.
Cool. That sum to 84.
I had a 76, -76.
Oh, negative. Oh, that's negative. Duh. -76. And then we divide that by 24 to get our mean of -3 point, what'd you say again?
67 or 1.67.
So 17?
Yeah.
Okay, perfect. So we're losing, every time we come up to this game, we're losing $3.17. And so that's what a lot of us. That make sense? So now, if 300 people play this game, how much is the carnival going to expect to make? What do you think we're going to do with that 300? So this can help us project how much are we going to make. If every time someone steps up to the game, we expect to make $3. And now we got 300 people playing the game. What are we going to do? Jaden's kind of making the motion of, we're going to multiply. We're going to multiply all those, right? So somebody steps up, that's $3. Another person steps up, another $3. Boom, another person steps up, another $3. So we're going to take 300 times that -3.17. I'm still going to need you, Michael.
You said 3.7?
Mm-hmm.
951.
951?
Yes, ma'am.
You got any change that I'm missing?
No, I ain't got no change, bro. Let me try one more time. I ain't have no change.
Yeah, I want some change, man. I want every penny I can get.
I get no change.
No change? Okay. Why do you think there's no change? Because we multiply by 300. Whoop, whoop. So,
Is that what?
yeah, is the amount the carnival expects to make from this game. Now, we know just by looking at what we did. Now, you guys could have also taken just what you got from your calculation from your 1,000 rolls and multiplied that by 300. You're still going to get roughly close to $951. It might be off a little because some of us had, $2 something, but it's going to give you a good idea. And this is what, people use to project how much money they're going to make off events. If they know off each individual what they expect to make and they know how many people they expect, then they can forecast what profit they're going to make. And then the last concept is the idea of called breaking even. When money is involved, a fair game is one in which the expected value for both parties playing is $0. So this is called breaking even. How much should the player pay to play this game? So right now, when the player comes up, how much are they paying?
$5.
Yeah, so when they're paying $5, and so I'm going to add that into my statement here. When the player pays $5. So right now, when they pay $5, they're losing $3.17. What would the carnival have to do if they don't want the player, if they just want the player to break even? What would they have to do with the cost to play the game?
Lower it.
Yeah, they'd have to lower the cost. And how much they should lower the cost is what they're expected to lose. So I'll take the $5 that I'm paying right now, and let's lower it by $3.17. And that's going to save me the exact amount of money to get me to now break even. So the cost should be, I should have written cost over here. Cost to play should be $5, which is the current cost, but take down the cost of what I'm expected to lose. And now I've got $1, what is that, 83 cents to play the game. Now when I play, I'm probably going to break even. Now I might be up a little, I might be down a little, but I'm not going to be up an enormous amount of money. And then you can run through the scenario again if you want with having the cost to play $1.83, and you'll see the mean comes very close to 0. So I think that's it for the first question. I'm gonna clear my can I clear this yet, or are you guys still looking at what I wrote?
I'm glad.
You're okay? Okay. So I'm going to stop my share. The second problem on this, make sure, I'm going to probably post what the probabilities are, because I don't want you guys to lose points because of your geometry. So I would be very careful on that dartboard, but it's going to be pretty similar to what we did for the dice. Okay, but make sure you don't continue with number 2 until you know, or you've checked with the tutor that your probabilities are right, because it sucks to do it and then have the wrong probabilities and have to redo the whole thing. All right. Okay. Any other questions before we go? I highly recommend this worksheet is due at 11:59 tonight. So I highly recommend you hitting up a tutoring session today to make sure it's right. We've got them at noon, and we've got them from 4 to 5. And then I think Professor Yee is on tonight at like 7:30. So make sure you hit up a tutoring session to check your results. Sound good? Okay. Good work today. I want to see you guys. I'm watching your monitoring sheets. I want to see you guys coming on time when you're in I know the morning ones are the hardest ones, but please keep getting here on time, because the sooner you can get started, the more work you can get done. More work you can get done, the sooner the 6 weeks will be over. Okay? BJ, you're on time next time?
Yes, ma'am.
All right, I appreciate it. You guys have a good day.
Jamie, don't do your hair long. You see my growth.
Later.
You see that growth. Stop it, man. You see my look at it.
Hey.
Ooh, yours. You ain't got no hair. Get out of here.
Got braids. What are you talking about?
I got, man. Don't have to. First off, y'all know my hair was long as heck. I used to have a dress. Like my
Do I have to end the meeting for you, BJ? Oh man. You guys, Samantha, you good?
Oh, I was gonna ask a question.
Okay, go ahead.
Okay, so for my green card, it just says the last tutoring session is from 4 to 4:50, but I have work until like 6 or 7. So I wanted to go to the later one. Where would I go to find that?
I think I'll put it in an announcement. Yee's gonna be, I think he'll be in his Zoom 1 room. So I'll put a link like I did yesterday. Okay. I put the announcement with Kalisher. Yeah. Did you see that one?
Yes, I did.
Okay. So I'll do a similar thing.
All
okay.
Right.
All right. Thank you for attending a different session. I appreciate that.
No, of course. Thank you for letting me or accommodating my schedule.
I like the color of your room. My daughter would love that. So very cool.
Yeah, the
teal. You're like,
I didn't know it was gonna be that bright, because when we picked it out, it was supposed to be like
more mellow,
seafoam green. On the camera, it looks really teal, but it's more like greeny. I don't know.
Oh, interesting.
But it's like really bright, and I didn't know it was gonna be that bright.
It's always interesting from seeing it on the thing to on the wall. Okay.
For sure.
Yeah,
All right.
all right.
Have a good day.
You too. Bye bye.